All right, so here we go with a rather interesting historical anecdote, if you will, from the history of science and the study of electricity. But in any case, this is something that we have to learn because this is still the way we talk about things in certain aspects when we're discussing electric current. It's still the convention, even though it's really kind of wrong. But way back in the past, the scientists didn't know which way current actually flowed. They had to kind of guess or pick which way they thought it was flowing or what they thought was flowing before they ever knew that such a thing as protons and electrons existed. So, anyway, those early pioneers of electricity, they decided to say that in a circuit, current flows from the plus, that's this long one here, this short one is the minus. By the way, what we have here is an electrochemical cell and a wire, and that's it. It's just a very simplified circuit. And we say that this side is the plus side. So the guys in the past had to pick, are we going to talk about current flowing as positive charges, or are we going to talk about current flowing as negative charges? And they decided to say that positive charges are flowing. So if positive charges could flow, they would flow this direction around the circuit, from the plus around to the minus, right? Those positive charges are contained in the protons of all of this metal, all the protons in all the nuclei of this metal. And as you guys probably know, the nuclei of atoms can't move, right? You can't have mobile nuclei inside of a solid wire. They sit in place. I mean, they vibrate a little bit, but they're not able to flow around the circuit. They're locked in because this is a solid. So the positive charges can't flow. So, again, the convention was made long before scientists knew that there was such a thing as protons and electrons. And the protons are in a nucleus and the electrons are free to flow. Nobody knew that. So they decided to say that positive charge was flowing, and that's still what we call conventional current. So if you use the word current, what you mean is the direction of positive charges flowing, if they could flow. Of course, what actually happens in the real world, as we understand it now, is that electrons flow out from the minus side and around to the plus side. That's this green one here. That shows the direction of electrons flowing. So the actual electrons flow through the circuit this way, right? But conventional current has been determined to be the other direction. And there's a lot of things that we talk about and symbols that are used and the way things that circuits are designed and things like that really kind of depend on the idea of positive charge flowing this way. So it's really hard to change it. There's a lot of inertia in the conventions. It's really kind of tricky kind of idea, like why do you have two directions of flow? But that's the way it is, sadly. Alright, so again, we're going to go into a little bit more detail here. I kind of talked about it all on the first slide, but we'll use a little bit more detail and summarize. Conventional current is the direction that positive charges would flow if they could flow. So here's another circuit. Plus side here, minus side there. So that's conventional current. It goes from plus to minus. The flow of electrons is the direction that the electrons actually flow, according to our current understanding of electricity and atoms. So electrons come out here and go around there. It's opposite, all right? So the flow of the electrons is opposite to the direction of conventional current. So then the question is, why do we still talk about and use conventional current in engineering and science? And the simple answer is, yeah, like I said at the beginning of this video, conventional current was established before we knew that electrons were the carriers of electric charge. And now the conventional current is convention. It's deeply ingrained in all of the symbols and vocabulary and design of the circuits and everything else that's used in the field of electricity. So it would be really a major undertaking to overhaul it and switch the way that we talk about it. So at least for now, until there's some kind of major motivator to switch the way we talk about it, a 50-50 coin flip of which way current flows and which is the carrier of the charge, the plus or the minus. Way back when scientists were first studying this, that 50-50 coin flip left us with conventional current today, and that's just what we have to live with. So make sure you understand, bottom line, if we say current, we mean the flow of positive charges, but if we ask which way the electrons are flowing, it's opposite to the flow of conventional current. Because again, conventional current is the direction that charges, positive charges, would flow if they could flow, but they can't flow. It's the minus charges that flow. Anyway, I hope that's not too confusing, but just keep in mind, a lot of the time when we're talking about this, we're going to talk about current, and you just have to imagine that the current is flowing from plus to minus, when you know, in fact, that the actual electrons are flowing from minus to plus. All right. Not a very fun topic, but certainly interesting, I suppose. And that's it for this video. Thanks for watching, and we'll see you next time.